I mean, imagine trying to orchestrate a four-destination live production, but your entire broadcast hub is literally just a single Ethernet cable.
Oh, yeah.
Today, we are tearing into the official spec sheet for the PTZOptics PT12X-STUDIO-SE-GY-G3 Hive-Linked camera. Our mission for this deep dive is to decode this really dense document and uncover how this specific piece of hardware acts as a massive workflow shortcut for modern content creators.
Well, looking at the raw numbers on this sheet, the 8.4 megapixel, 12.8-inch CMOS sensor, the 1080p 60 capture paired with the 12x optical zoom. I mean, it's easy to just write this off as another standard HD camera.
Right.
Because we all know 1080p isn't exactly breaking new ground in a 4K world, you know? But the resolution isn't the real story here.
Right.
No, the real engineering feat is the internal multiplexing.
Okay, let's unpack this because it's outputting to HDMI, 3G SDI, USB-C, and IP all simultaneously.
All at once.
I look at this like a multi-lane highway for video. Pushing a 1080p signal out of one port is just a country road, right?
Yeah.
But pushing it out of four entirely different physical and network protocols at the exact same time, that requires a highly synchronized traffic control system inside the camera. How does the internal processor handle that encoding load without, dropping frames or just melting down?
Well, it comes down to highly optimized silicon that's dedicated specifically to network routing rather than just raw image processing. And what's fascinating here is the native NDI HX3 support.
Oh, the HX3 protocol.
Exactly. You're probably already familiar with standard NDI, but HX3 is kind of the sweet spot. It gives you the visually lossless quality of full bandwidth NDI, but at a fraction of the byte rate.
Wow.
Yeah, with latency well under 100 milliseconds. The heavy lifting is all done by the camera's internal encoder before the signal ever even hits your switch.
That's huge.
Plus, the word native on this spec sheet means no firmware paywalls or extra licensing keys to manage.
No extra fees.
Right, you just drop it on the subnet and the HX3 stream is instantly available.
So that explains the bandwidth efficiency, but it leads right into a massive logistical question for me.
Okay, what's that?
If this camera is acting as its own traffic cop, routing sub-100 millisecond video across four protocols at once, the control interface has to be incredibly robust.
Oh, absolutely.
The spec sheet lists Hive Studio integration, IR remotes, web UIs, mobile apps, and serial joysticks.
I'm going to push back on this design philosophy a bit.
Oh.
Yeah, for a solo creator or a lean corporate AV team, isn't this an overwhelming overkill of control surfaces? Providing 6 different ways to steer the camera feels like it introduces too many points of failure.
Well, having multiple control inputs doesn't mean you use them simultaneously, right? It provides redundancy and workflow integration.
Okay, fair enough.
Like the Hive Studio link connects the camera directly to PTZOptics online platform. You bypass the local network hurdles entirely.
Oh, I see.
So if you're running a remote production, your producer can control the PTZ mechanics from a web browser across the country, while the local operator just monitors the physical SDI feed. Let's factor in the power delivery then, because that adds another layer of heat and complexity. It accepts standard 12-volt DC, but obviously everyone is going to use power over Ethernet.
Yeah, PoE is the standard now.
You're telling me this single device is pulling power, driving mechanical pan-tilt zoom motors, encoding an NDI HX3 stream, and multiplexing 3 other hardwired video feeds over one single Cat6 cable.
That's exactly what it's doing.
The thermal management alone must be intense.
And that thermal threshold is exactly why it's capped at 1080p 60 instead of pushing 4K.
Ah, that makes perfect sense.
Right. By limiting the sensor resolution, they free up the thermal and processing headroom required to run those robust IP features and the mechanical motors over standard PoE.
So it's a deliberate trade-off.
Exactly. It allows a solo operator to completely eliminate studio cable clutter. One wire handles the power, the control data from Hive Studio, and the HX3 video feed safely and efficiently.
You sacrifice 4K resolution to gain an ultra-reliable, fully integrated broadcast node that won't overheat on a PoE switch. That makes a lot of sense for live environments where latency and stability just trump raw pixel count.
Without a doubt.
For you listening, whether you're upgrading a home studio or managing corporate AV, this hardware is designed to kill your workflow bottlenecks. Currently, it's priced at $949, and utilizing that 5% off code at checkout makes this level of internal processing incredibly accessible.
The shift from passive lenses to active network nodes really changes the entire architecture of a studio, which raises an important question for you to ponder as you map out your next upgrade.
What's that?
Well, if our cameras are becoming fully self-contained network hubs that encode, switch, and stream directly to cloud platforms entirely on their own, how long before the traditional computer-based control room becomes completely obsolete?
That is the million-dollar question. If the edge device does all the heavy lifting, the center of the network just disappears. Something to chew on next time you're racking a switcher.